Hi all, in this particular video we will see what is linked list and the types of linked list and how to insert a node at the beginning of the linked list. So now let's get started. Linked list is a dynamic data structure consisting of nodes where each node contains data and pointer field. So what is dynamic data structure? We can increase the linked list size as you want, or we can shrink or decrease the linked list size at the runtime. Based on your requirement, we can decrease or increase the size. That is the meaning of dynamic data structure here. So unlike arrays, linked lists do not store elements in contiguous memory locations. In arrays, every element will be stored in contiguous memory location, but in linked lists, the elements are not stored in contiguous memory locations. So they are stored in different memory locations and they are interlinked with the pointers fields or interlinked with the address fields. Okay, that is the difference between arrays and linked list. There are three types of linked lists are available. One is single linked list. Each node points to the next node. Double linked list, where each node points to the both previous and next node. Okay, circular linked list, the last node points to the first node, so that forms the circular linked list. We will see these types of linked list in our upcoming lectures. As of now, in this particular video, we will see what is a single linked list and how do we insert a node at the beginning of the linked list. So now a linked list will be looking like this. Suppose we have three nodes 10, 20, 30 and the memory addresses are 100, 200 and 300. They are linked with each other by the help of address field or pointer field. So for example, here this node is having 10 as data and 100 is the this element address or this node address, and we are having another node called 200, that is the 200th memory location. This 200 will be stored here so that the linked list will be interconnected, so that the link will be formed between these two nodes. So that is the meaning of linked list. So how do we define the structure of a node? By using a structured node, and here we have two fields. One is data field and another one is pointer to the structure of same data type. This is called self-referential structure. So now how do we insert a node at the beginning of the linked list? For that, we are having one pointer called head. Initially the head pointer will be null. Okay, this head pointer I have declared globally. Okay, now let us try to add a node at the beginning of the linked list. The logic as follows. For example, this insert at beginning function will accept only one value, that is the node value, whatever the data value of the node. So now we are here struct node pointer temp, so that we are trying to create a node. Struct node malloc. Malloc is a dynamic memory allocation function which is used to create a block of memory in the heap, because it is a dynamic memory allocation. So whatever the memory is going to be allocated, that will be in the heap memory section. Okay, so malloc accepts one single argument. With the help of size of, we are defining the how much memory should be allocated at the runtime or in the heap. So based on the structure node, the memory will be allocated. Okay, so malloc will returns the void pointer. So in order to point to structure node, we have to typecast with the structure node pointer, so that it will point to structure node pointer, because malloc will return the void pointer. In C language, this typecasting is not at all mandatory, but in C++, this typecasting should be mandatory. So if you remove this typecasting line, then that is a no problem. This will work fine. Okay, so temp data. So we are forming one link. I mean, we have created one node. In that temp data, first we have to store the value in temporary data. So whatever the value is, so let us assume the value is 30. That 30 will be stored in the temp data part. Okay, now next one, the head address. Initially the head address is null, so that null will be assigned to temporary next part. So the temporary next part will be the null part. And what is the temporary address? The temporary address, let us say 100. That 100 will be assigned to head. So head pointer now move to the, previously the head is null, right? Now the head pointer moves to the first node. Okay, that is the meaning of this entire logic. Now we will see the full code. In order to use these functions called malloc and null, we have one standard library called stdlib.h. In this function, the dynamic memory allocation functions such as memory, malloc, calloc, realloc, free, these functions are defined in this particular library called stdlib.h. Now let us try to decode this code. Instead of wasting so much of time here, now let us jump to the tracing part. That will be interesting. So the tracing looks as follows. Now we are at the in main function, we are calling the function as insert at beginning with the value 30. So 30 will be forwarded. So this is a call by value, right? So 30 will be forwarded to insert at beginning. So we are creating a one node by using this malloc function. That pointer is temp. So one location got created now. Don't assume any values here. For example, the empty box is created with two fields. One is data field, another one is address field. That is what the expectation is. Now in temporary data, the x value should be placed. What is the x value? Is 30. That 30 will be placed in temp data. This is temp and this is data part. So that data part will be assigned to, that data part is now 30. So 30 is assigned to the data part. That's what I am trying to say here. So what is the head location? Previously the head location is null. Okay, initially the head is null, right? So null will be assigned to temporary next. The temporary next is here and the null is placed here. This is how we have formed the node. And whatever the head is null, right? Now the head should be moved to the first node. That is the meaning of it. So what is the temporary address? Temporary address is 100. That 100 is assigned to head. So initially the head value is null. That head will now point to 100th location. So both head and temporary pointers points to the this particular node. That is the meaning of first function call. After the 30th node is created, after the node of 30 value is got created, we have called this function again with 20 as parameter. So again insert at beginning 20 is called, and another one more node is got created. Temporary data, whatever the x value is, the x value is now placed here. And what is the head value? Head value is previously 100. That 100 will be placed here. So that is how these two are interlinked. Now what is the temporary value? Temporary value is 200. So head should be point to the 200th memory location. Initially the head is at 100th location, now head is at the 200th location. So this is how insert at beginning function will works. Similarly, we have called the insert at beginning function with the 10 as parameter. The same working principle is applied here. So 10 200 will be added at the beginning of the list. Okay, that is the meaning of insert at beginning function. Now how do we display this function? So as you observe the full code, in this full code we have created one function called void display list. So by the help of this function, we are traversing the each node of the linked list and we are printing that node value. Okay, so how do we do that? Now let us try to trace this function as well. So coming back to the display list function, now we have created one pointer called temp. That temp should be pointed to head. So initially the temp and head both are pointing to the first node address. So while temp not equal to null, so what is the temporary address? 300. Is 300 not equal to null? The condition true. Printf %d arrow mark. Where should I refer? Temporary data. What is the temporary data? 10. That 10 will be displayed here. Now temporary pointer should point to the second location, whatever the second node is. That movement should be there. So temp is equal to temp next. What is the temp next address? 200. So temp will point to the 200th memory location now. So in the next iteration, is 200 not equal to null? The condition is true. So now 10, 20 will be displayed and temp should be moved to the next location by the help of this this statement called temp is equal to temp next. So initially that means currently the temp is pointing to the 200th memory location, right? So temp next, that is 100. This 100 is assigned to temp. So temp will move to the 100th location. So I'm not able to describe in this diagram, but please follow the tracing part, you will understand this. So is 100 not equal to null? No, 100 is not equal to null. Now 10, 20, 30 will be displayed. Now temp should be moved to the next location, but the temp next value is null. So temp will be assigned to the null. So we are moving to the further next iteration, but this time null not equal to null, the condition is false. The loop will break now, and at last we have null. That null will be assigned here. So by the end of this function, 10 arrow, 20 arrow, 30 arrow, null will be displayed onto the output screen. This is the working nature of inserting a node at the beginning, and how do we display the linked list by using this function. So with the help of this function we can display the linked list nodes. Now let us try to run this code in devs.app. So we have defined the structure node with the two fields. One is data field and another one is next field. That is a self-referential structure. And as I said earlier, head is a global variable which is having null as an initial value, and we have written insert at beginning function and as well as display list function. And as we already know, the control will flow from the main function. So initially insert at beginning function is called, that will be 30 is got created, and we are immediately displaying the list. So once 30 is added, 30 and null will be the initial display function, initial linked list. And once the insert at beginning 20 is also called, now 20, 30, null will be the display list. and at last we are calling insert at beginning with 10 as parameter. After this function called 10, 20, 30 and tends to null will be the final linked list. Now let us try to execute this code, execute and compile and run. So as you see here, 30 null, that is a initial linked list, and after 20th call, after the second call, 20, 30 null is the second expected output, and finally 10, 20, 30 null is the final linked list. So this is how we can insert a node at the beginning of the linked list. In the next video we will see how do we insert a node at the end of the linked list. Thank you so much for watching.